Hey there, it's Mrs. Stipe. I'm back. We're starting Chapter 6. So in Chapter 6, we spend a lot of time solving trig equations. And so we're going to start out right in the beginning with a very, very simple one to solve. And so you're asked to solve sine of x equals 1/2. And so in words, what this is doing is saying, tell me the angles whose sine is 1/2. All right, so maybe this is good. You have a picture in your mind where you've graphed y equals sine of x, and then you've graphed a horizontal line at y equals 1/2, and you imagine that you're finding in one cycle those two solutions. All right, from your exact values, you have memorized that the sine of a 30-degree angle is 1/2, and then also in the second quadrant 150 degrees has a sine of 1/2. So if the directions are to find the two solutions from 0 to 360, you would be done. But sometimes they ask you to find all the solutions. Now we remember that the sine curve continues on to the right and to the left forever, that the domain is all real solutions, and so it is not possible to list, right? When I say find all solutions, I don't mean list them. What I mean is to somehow tell me what those solutions would be. So here's what we do. We start out with the 30-degree, and we say it that we'll get to 1/2 every time we go another 360 degrees. And so the way we write that is that 30 degrees plus 360n, where n is an integer. Okay? The reason it has to be an integer is because we want the positive and the negative values. Likewise, 150 degrees plus 360n will give us together all of the solutions. All right, hopefully that makes sense. Let's go on to the next one. They get a little bit more complicated. Let's try this one. What about if I have 2 sine of x is equal to 1? The directions are to solve. And this time I want solutions from 0 to 2 pi instead of 360. So we know we're in radians, and then what the heck we'll do all solutions as well. All right, and so in this case we have to do a little bit of algebra, not too much. We're going to divide both sides by 2. We get sine of x equals 1/2. The solutions are the same, but because we're in radians, we're going to call them pi over 6 and 5 pi over 6. And then all solutions, pi over 6 plus, instead of 360, 2 pi n, and 5 pi over 6 plus 2 pi n. And that takes care of all the solutions. All right, in solving equations, factoring plays a big part. So nearly all, the majority of solving equations will involve factoring of some kind. So let me go ahead and write this equation. We're going to solve sine squared x is equal to sine of x, and we'll go back to degrees for this one. So we'll say we want to be from 0 to 360, and then what the heck, we'll do all solutions as well. Okay, so we are tempted to go ahead and divide out that sine, and I just want to say that that is not allowed. And the reason that is not allowed is that sine of x could be equal to 0. And we know at this point that we can never divide by 0. That's never allowed in math, okay? So we don't divide. What we do instead is factor. So let's go ahead and bring everything over to the left side, subtract that sine of x, and then remembering our greatest common factor, we factor a sine of x out, and we get sine of x minus 1 equals 0. Right? Zero product property says that we set individually them equal to 0. And so our solutions, the sine of x is 0 at 0 and 180 degrees, and the sine of x is equal to 1 at 90 degrees. And we're done. So our solutions are 0, 90, and 180, and then those are the specific answers, and then we would say 0 plus 360n, 90 plus 360n, and 180 plus 360n if they asked for all. Okay, hopefully that makes sense. So now you're saying to yourself, that's not too bad, but Mrs. Stipe, I bet it's going to get harder. So here we go. This is the last one we're going to do to show you sometimes they get to be pretty challenging. So what about if I have sine squared of x minus 3 sine of x plus 1 equals 0. And your job is to solve for x. Okay, so hopefully this reminds you of those problems we factored using u substitution, right? And so we pick u to be the sine of x, and the reason we do that is that then this becomes really simple. U squared minus 3u plus 1 equals 0. Okay, is this coming back to you? I hope so. I'm thinking that you haven't forgotten everything from first semester. I'm hopeful. Okay, problem here though is as much as we'd like it to be factorable, there's no way you can multiply to 1 and add to negative 3. So when that's the case, we have no choice but we have to do the quadratic formula. So here we go. A is equal to 1, B is equal to negative 3, and C is equal to 1. So using the quadratic formula, we've got 3 plus or minus the square root of negative 3 squared, which is 9, minus 4 times A times C, which is just 4, all over 2 times A, which is 2. So here's what we've got. We've got 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. All right, when we put these in our calculator, the first one gives us approximately 2.618. Right? We're going to throw that answer out, and I hope right away you can say there is no way the sine of x can equal 2.618. Right? Here's your sinusoid, here's 2.618, they never meet. Another way of thinking this is that when the sine is greater than 1, what we're saying is that the opposite side is bigger than the hypotenuse. Can't happen. The other one, when we put into our calculator, we get approximately 0.382, and that's an okay answer. Now, what we found was u, and we don't want to know u, we want to know the sine of x is equal to 0.382. What does that mean x is? All right, so when I get this, what I'm saying is I have an angle x whose sine is 3.812. So the way we find that angle is we get our calculator out and we do this. Okay, when we do that, we get approximately 22.5 degrees. All right, so what that means is that if we put 22.5 in that original equation, right, so the sine squared of 22.5 minus 3 times the sine of 22.5 plus 1, we should get really, really close to 0. And I checked. We did. You could check if you'd like to. But then we always want to be considering that around the circle, there are usually 2 values for every solution to this. So there should be another place where the sine of x is 0.382. So we remember that when theta is in the first quadrant, right, the sine of theta is positive in both the first and second quadrant. So if we draw a reference angle of theta, we should get the same 0.382. Right? So how do we find the rotation angle? And the way we do it is we take 180 minus 22.5. And so we're saying at 150, oh no, not 58, 157.5 degrees, the sine is also approximately 0.382. So our two solutions, 22.5, 175.5. Okay, great. That's a lot to consider. We will spend 3 days working on trig equations and you'll get really good at them. See you in class.